Welcome back, guys. It's AG. You're watching Math to the Max, and today we'll discuss the basic derivative rules. Well, we got to know the notation first. So when they say f prime of x, that just means the derivative. Or they may say dy dx. dy because y is always the output. It doesn't have to be y, but that's our normal notation for y is the output, x is the input. So the derivative of y respect to the derivative of x, or they may say the derivative respect to x of this function, or y prime. The constant rule, the derivative of a constant is 0. The derivative of 5, 0. Derivative of 3, 0. Derivative of 2, 0. Derivative of -1, 0. Derivative of a constant, 0. Linear rule. So y'all remember y equals mx plus b. So we know it's linear because it's x to the first power. Indivisible 1, right? So what's the linear rule is when you have a linear function, the derivative is just the slope. So 5x, 5. 2x, 2. What's the derivative of x? Well, what's the number in front of x? Invisible 1. Then you have your power rule. How we know we're applying the power rule? Well, when you have a power. What is a power? It is an exponent. Exponent. So check it out. You bring your exponent to the front as a leading coefficient. So the n becomes in the front. And then you always subtract 1. All right, we'll see when we do our examples. That's our vocabulary. Next, what are our prerequisites? Converting between radical and rational exponents. Let's look at an example. So this is your base or standard form. So you got the square root of a to the m power is equal to a raised up to the m over n. M over n is the exponent, guys. M over n is an exponent. So if your radical does not have an n, it is understood as a 2. So that's like the square root. It's an invisible 2. If you don't have a power for that radical, we know that's an invisible 1. Knowing, hey, your negative exponent rule. So all that means is you do the reciprocal. So that means flip it, flip it, flip it. And you change your exponent to a positive. That's your negative exponent rule. And subtracting fractions. In order to subtract fractions, you got to have a common denominator. Common denominator. So what's the process? Determine which derivative rule is needed. Is it a constant? Is it a linear? Is it a power? If the power rule is needed, you have to make sure you have an exponent and you bring it to the front and subtract 1. All right, y'all already know what time it is. It's time to go to work. All right, number 1, f prime of x means find the derivative of the f function. So let's go up to the f function, which is 4x. All right, 4x, that is a linear function. So we know the derivative of a linear function is the slope, which is 4. Final answer. Number 2, find the derivative of g respect to x. Respect to the derivative of x. So let's look and see what the g function is. The g function says g of x equals the q root of x. We need to change that radical to a rational exponent. So that becomes x to the 1/3. Why? You remember the invisible power is a 1 and the root is a 3, so it's x to the 1/3. So now, since we know that is a power, how do you find the derivative of power? You bring the power to the front, so the 1/3 goes to the front, and then you subtract 1. This is when you subtract your fraction. So what's 1/3 minus 1? You got negative 2/3. All right, so that's our derivative. Now, sometimes you might want to rewrite it as a positive. So that's where you got to use your negative exponent. Rewrite your negative exponent as a positive. You can bring it to the bottom. And then we know the rational exponent can always be rewritten as a radical. So those are all your different options. Final answer. Find the derivative with respect to x of the h function. What's the h function? It's 4x to the third power. So since that's a power, just go ahead and bring your power to the front. So what's 3 times 4? That's 12. And remember, I always got to subtract 1 from the exponent. So that's your final answer. 12x squared. Or j prime of x means find the derivative of the j function with respect to x. So let's go up here to the j function. All right, because that exponent is at the bottom, we want to rewrite it by putting it at the top of the numerator. So I'm using my negative exponent rule. And now since I just have a power in the numerator, I can just bring it to the front using the power rule and subtracting 1. When I do that, I get negative 4 times 2 and then negative 4 minus 1. When I do the math, we get negative 8, negative 5. That's your final answer. However, I can rewrite it as a positive, like it initially started with at the top as a positive, by doing my negative exponent rule, meaning the reciprocal. So your base will go at the bottom and you change the sign. Final answer. Number 5. Find the derivative of k with respect to the derivative of x. Alright, that's a constant. It's a constant, y'all. Derivative of a constant is 0. L prime of x means find the derivative of the L function with respect to x. Right now, this is 2 parts. So you're just going to take the derivative of the 5x part and then take the derivative of the 3 times the square root of x. However, when it's always a radical, you remember it's recommended you change it to a rational exponent. So let's do that. Alright, so you should get 3x to the 1/2. I just brought the 5x down. Alright, so now this is a linear function. 5x is linear. We know the derivative of linear function is the slope, so that's going to just be 5. And then we do the power rule on the 1/2. Bring the 1/2 to the front. And then we need to subtract 1 from that exponent. Alright, so when we do that, that's what we get so far. You can stop right there, just sometimes depending on what's the problem asking, when you have to solve them later and plug in numbers, it's easy if you rewrite it back as a radical. So I put it at the bottom using the negative exponent rule, and then you could rewrite it back as a radical. So either one of these is correct. Final answer. All right, 7. Find the derivative with respect to x of the m function. The m function is up here. I always change a radical, so let's change that. And then apply your power rule. All right, I'm gonna let you go ahead and do that one. Go ahead and do that. This should be mental math. Boom. All right, you should have it. Check it out. That's when you brought it to the front. Let's subtract that 1. And of course, you can rewrite it by always doing the negative exponent rule. If it's a negative exponent, you can always change to a positive by putting it in the denominator. If it was in the numerator, it always switches from top to bottom, bottom to top, wherever it started. And you can rewrite it as a radical if you like. And that radical answer will be negative 10 over 3 times the cube root of x to the 8th power. All right, now we're done. Now you know how to find the derivative using basic rules. Thanks for watching. Make sure you like, comment, share, subscribe. Until next time, always striving for excellence and reaching for success.